A tennis ball of mass m1 moving with initial velocity u1 collides with a soccer ball of mass m2 initially at rest. Okay, after the collision, the tennis ball is deflected 50 degrees from its initial direction with a velocity v1 as shown in the figure. Suppose, okay, given all the data here, mass 1, mass 2, initial velocity 1 and final velocity 1, calculate the magnitude and direction of the soccer ball after the collision. Okay, first of all, from here, this is a one-dimension or two-dimension collision. So from here, we saw an angle, isn't it? So confirm this is a two-dimension collision. Okay. In the case of two-dimension collision, you need to do x and y components. Okay, for the momentum, right? For the momentum, conservation of momentum, P, you need to do two components, x and y. Okay, first of all, we have two objects. One is a tennis ball. Another one is a soccer ball. Okay, tennis ball is M1. Soccer ball is M2. Okay, so maybe you can write over here. Okay, this is the M1 is the tennis. Okay, and M2 is the soccer ball. Yeah. So, this tennis ball collide with soccer ball. The tennis ball, yeah, this is the tennis ball. See that? The tennis ball deflected 50 degrees. Tennis ball deflected 50 degrees below the positive x-axis. Okay. So now he wants us to find what happened to the soccer ball. What happened to the soccer ball? What is the magnitude and direction of the soccer ball? So this one is for we want the velocity. Okay, magnitude and direction of velocity for soccer ball after. So this is about v2. We need to find v2. So we can actually assume this is the mass 2. Okay, the soccer ball, okay, is deflected, should be around deflected this way. This around should be around here. Yeah. So we need to find this one, yeah, and also the direction. We need to know the direction theta. Okay. So let us do it. Two components, x component and the y components. Right. So we use conservation of momentum. Yeah. For this question, we use conservation of momentum. Conservation of momentum. We use okay. So we make a divider here. Make a divider. Now, M1 make two components. M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. Remember, this is x component. You need to label the velocity with x component, yeah, or with x component. Alright. So the same thing we do for y component. We also use the principle of conservation momentum. M1 U1, M2 U2, M1 V1, and M2 V2. Yeah. But all of these are y components. So label all the velocity with y components. Okay. Now, okay, for the U is the before collision, V is the final after collision. Yeah. So just want to, okay, this is before. Okay. This is before collision. This part is before collision. The right hand side is after collision. Similarly for the y component, here is before collision. and this is after collision. Now we do by components. Let us first of all look at the x components. Okay, remember 1 is for tennis, 2 is for soccer. Okay, we already have the data here, but this one is in gram, so better we make it into kilogram. Yeah, maybe you should rewrite the informations somewhere. Okay, we rewrite the information. Okay, mass 1 is 250 grams, so convert to kilogram. Okay, remember this one is a gram. You must change to SI unit. So mass 1 is 0.25 kilogram. So you just write at the diagram here 0.25 kilogram. Okay, how about U1? Okay, U1 is 20. So this is 20. Okay, and then mass 2 is 900 grams. So mass 2 is 900 grams, so it's 0.9 kilogram for mass 2. That's a soccer ball. And then we have also the final velocity one. This is the tennis ball. Okay, so right over here it is 4 for this one. So we need to find V2. Yeah, we need to find V2 and also the direction theta. Okay, so now we can continue. Yeah, we can continue. First of all, let us just do the okay, hold on a second. Yes, set it as background. Right. Okay, so let us first look at the x components. Yeah. Okay. Remember, this is the before collision. Before collision is here, and this is the after collision. Yeah. So for before collision, just look at this part. After collision, look at this part. Okay. So now we can do it. Yeah. Mass 1 is 0.25, so just put it 0.25. Do x component first. Now for U1x, before collision, U1 is only has x component, it doesn't have y component. So this also is going to the right. Going to the right is positive. Yeah, direction velocity to the right is positive. So this 20 is totally in x component, and it also in the to the right positive direction. So we just write it as positive 20. Okay, that's it. And then for the soccer ball M2, the initial velocity. What's the initial velocity for soccer ball? Okay, the U2. U2 is 0 because it's stationary at rest. You see that? Soccer ball initially at rest. So U2 is 0. So what I can say is this one is 0. So this one plus 0. Okay, none from soccer ball. Okay, so let's continue. Now look at after collision. Yeah, just look at the x component. Yeah, the x component of velocity. Okay, look at the M1 tennis ball. Okay, the mass is still 0.25. Okay, 0.25 kilogram. Okay, look at V1x. So V1x, we want only the x component. So you look at here, V1, it has two components. It has the x component and also the y components. You see that? How? Yeah. Okay, maybe I should draw it over here. Yeah? Draw it over here. Okay, this is the this is the V1. Okay, so what is the angle here? The angle here is 50 degree. 50 degree, isn't it? 50 degree. So for V1x, yeah, this is for, I just redraw this one to here. Yeah, the tennis ball I just redraw to here. That's the for after collision. Yeah, this is the V1x. Okay, so what is the V1x? Using what? Using cosine 50. It is V1 cosine 50, and this one is going to the right, isn't it? Going to the right is positive value. Yeah, it's positive value. Okay, this one is positive value. So we just write as a positive. Okay, we just write as a positive. What should I write here? This one is v1 cos 50. Okay, just rearrange a little bit. Yep. Okay, so I got it, v1 cos 50. Okay, and then look at the soccer ball M2. Okay, so M2 is 0.9 kilogram, so just write as 0.9. And then the V2 we just put as V2x. Later, this one actually you have two ways to write. We either write V2x or we write V2 cos theta. Okay, never mind. We put as V2x first. Yeah, so this one is just the x component of velocity 2. Okay, now let's solve this part. Let's solve the x component parts. Yeah, v1 supposed to be just substitute v1. What is v1 again? V1 just now is 4. You see that? v1 is 4. V1 is 4. v1 is 4. So just put this v1 as 4. So I think this formula you can solve already. Yeah, you can solve already. You can find v2x immediately. V2x is equal to, let's calculate. Okay, so I got the answer for v2x is positive 4.8413. Put 4 decimal place for more accuracy. Okay, meter per second. So this one positive means going to the right. Okay, positive means is going to the right. Yeah, positive in x component. Yeah, positive in x component means going to the right. If you get negative means to going to the left. Okay, right now we know that for v2x is going is positive, so that means, yeah, our prediction is correct. So our v2x this our v2x it is positive. Yeah, going to the right. Now we want to find v2y. Yeah, we want to find v2y, and then we do Pythagoras theorem. We can find v2 already. Okay, so let's find the do the y component. Okay, so the same thing. Now we just look at only the y components. So look at before collision. Before collisions, look at the M1, the tennis ball. Mass is 0.25. Just put as 0.25. Okay, and then u1y. Look at here. Do you think for before collision the velocity, is there any y component? No, this velocity u1 only x component, no y component. You see that? No y component. So we actually, this one just ignore. Yeah, don't put. So u1 only has x component, no y component. So the y component is 0. So u1y is 0. Understand? u1y is 0. So we can say the whole thing is 0. Okay, whole thing is 0. Multiply by 0. And then how about the mass 2 soccer ball? The velocity, the initial velocity u2 is 0. So of course no x component, no y component. So this one also 0. So what we can say is before collision it is 0. Before collision it is 0 entirely. Now how about after collision? After collision, look at the tennis ball. Okay, what's the mass of tennis ball first? Okay, it is 0.25. Now how about v1y? look at the v1. V1 has v1y. We want to find the v1y. So I amplify I magnify it to here. You see that? So this is the v1y. This is the v1y. So what's the v1y here? It should be the using this v1y should be using sine 50 because it is opposite the angle. So this one should be using sine, yeah, sine equation. Or we can say is v1 sine 50. But the thing is, it is going downward. It's going downward, so this one should be put negative sign because it's going downward. Okay, for x component is going to the right, is positive. It is positive, but for y component it is downward. Downward velocity, you need to put negative sign. So you should put here negative. If you don't put negative here, you're wrong. Okay. Then finally, this one is using sine 50. So it is actually v1 sine 50. V1 sine 50. Why sine 50? Why sine 50? Because it's opposite the angle. Okay. Why is it sine 50? Because it is opposite the angle. Why is it negative? Because it's going downward. The component y component is going downward. Okay. And then later on, okay, this one mass 2 is 0.9. Okay, 0.9. And then this one just put as v2y. We want to find v2y. And then v1 again substitute with 4 because v1 is 4. Substitute this one v1 with 4. Okay, so we can find the v2y already from here. v2y is equal to okay, so it is v2y, it is oh, I get a positive value again. Yeah, I get a positive value. Positive value, is it important? Important, because a positive means going upward is about the direction. 0.8512 meter per second. Why I put 4 decimal place? Because I want accuracy. So this one positive. Y component is positive, means it's going upward. The velocity is going upward. So what I can say about the v2? Yeah, v2 is going to the right and going upward. So I can safely write over here. Yeah, the v2y is actually going upward. v2y is going upward. So it's positive value. Okay, so can we find v2 now? Easy peasy. We can find v2 easy peasy. So we can actually redraw. Yeah, this is our v2x, v2y. Okay, our v2x and this is our v2y. Both are positive value. Yeah, both are positive. Because go to the right and upwards. So we can find our v2. We can find our v2, and then the angle also we can find. So how to find the v2? Tell me by yourself. Tell me how to find v2. Very simple. Just v2x square plus v2y square and then square root. You know the answer. So okay. So let's calculate. Come on, let's calculate together. Okay. So it is this one, it should be 4.92 4.92 meter per second. That's the final velocity. Now we got the magnitude. Now not enough, we need to find direction also. Direction it is using tangent theta. You know, tangent theta, we just take the opposite over adjacent, and then modulus it, make them all positive value, modulus it. Okay, so v2y over v2x, and then tan theta is anti-tangent. Remember, you need to anti-tangent. So what do you get? Okay, let's calculate also. Yeah, I got the angle as 9.97 degree above the positive x-axis. Why? You must say this one also. You must say this above positive x-axis. And why do I know it is above positive x-axis? Because, yeah, look at this diagram. The angle theta is above the positive x, above the positive x-axis, isn't it? The theta is above the positive x-axis. You must write this. You don't just write the angle, the direction. Don't just write the angle 9.97. You must write also above the positive x-axis. Okay, so that's the value, speed, and direction. Okay, is it correct? 4.91, 4.92, correct. Almost correct. 9.96, 9.97, almost the same. Above positive x-axis, correct. Bingo. Okay.